Hi, this is Module 2, Lesson 3, and video number 2. And we are on page 23, just like we were for our last video, and you see the problem right in front of us that you have also in your book. Mr. Perez pours 3 liters of water equally into 4 containers. How many liters are in one container? Okay, so now we have less water than we have containers. In our last problem, we had more water than we had containers. So a little bit different. And we're going to start with what can we draw and reading. Read, draw, write. And we have to do it in that order. So let's read a little more carefully. Mr. Perez pours 3 liters of water equally into 4 containers. And then the question is the same as the last time. How many liters of water are in one container? All right, so let's think about what we can draw, starting with the tape diagram. And oops, our tape diagram is going to represent 3 liters of water, right? Okay. Oops, gotta get my pen. There we go. There we go. Sorry, so messy. 3 liters of water and breaking it into 4 containers, just like last time. So we're going to do 4 containers. So the big difference is last time we had 5 liters and we were putting it into 4 containers. This time we have 3 liters and we're putting it into 4 containers. Okay, so trying to find out the value of this one right here. How much is in one container? Excellent. So what would be our division problem? 3 divided by 4. Okay, and 3 divided by 4 is a fraction. 3 divided by 4. And that's number on the top is smaller than the number on the bottom, so we don't need to change it to a mixed number. We can keep it right this way, right? So that means 3/4 of a liter goes into each one. Now we want to double check and make sure this is reasonable. Make sure this makes sense. If I have 3 liters and I'm putting 3/4 in each one, that's a little bit less than 1, right? A little less than 1, a little less than 1, a little less than 1. That would make sense. If our answer was more than 1 and we had 4 of them, then we wouldn't be able to divide up the 3 liters that way. So that wouldn't make sense. So we want to make sure that we know that our quotient is less than 1. Okay, that makes sense. So let's write our sentence. How many liters of water are in one container? 3/4 liters are in one container. All right, excellent job. Make sure you have that written down on page 23. If you don't, pause me and get it written down because we're going to move on to our next problem, which is, oh, I got to clear that screen. There we go, which is number 3 on page 24. Mr. Evans pours 11 liters of water equally in 4 containers. How many liters of water are in one container? Okay, so now he has 11 liters of water, and he's still putting it into 4 containers. But our amount of water is quite larger, isn't it? And we're still asking how much water is in one container. That's nice because we can actually get some good practice on this type of word problem. All right, so what can we draw? Can we draw a tape diagram? Well, yes, we can. And it's going to be just like our last tape diagram. Maybe you already have it drawn. 11 liters of water. And it's going to be divided equally into 4 parts. And then our question is how much is going to be in one part. All right, Now, what is our division expression? 11 liters of water divided by 4. 11 divided by 4. All right. Now, we know a fraction is the same as a division problem. So 11 divided by 4 is 11 fourths. If I tell you, hey, go put 11 fourths of water in this container, would you understand what I meant? Not really. So we really do need to change this one to a mixed number. We know we need to change it to a mixed number when the number on top is bigger than the number on the bottom, right? That's called an improper fraction. It's improper. It's not right because the top is bigger than the bottom. So we can do a division problem, 11 divided by 4, right? And these are both division problems right here. So we're doing either one of those. Okay, and 4 times 2 is 8. And 11 minus 8 is 3. So that means that each one of these is 2 liters. But how much is left over? 3. We're going to divide that 3 into 4 parts. So that is 3 fourths. Why are we dividing it into 4 parts? Because we have 4 parts, because that's what we're doing. We're dividing it into 4 parts. So 3 fourths. So each section is 2 3/4 liters. Each container is 2 3/4 liters. Now let's think, does that make sense? This is almost 3. So let's just round it up to 3. 3, 6, 9, 12. Yes, that would make sense. It's a little less, so that's why it's 11. And let's write our sentence. 2 3/4 liters are in each container. All right. Make sure you have that written down. If you don't have that written down on page 24, then please pause me and get that taken care of. All right, I'm going to go on to the next one. Here we have 3 equations. All right, what are the similarities and differences in these 3 equations? What do you notice? Similarities and differences in our 3 equations. I see 2 mixed numbers and 1 regular fraction. I see they're all divided by 4. So the divisor is the same on all 4, but the dividend, the first number, the number that's being divided, is different. This was the first one that we did, 5 divided by 4. This was our second one, and this is our third one. Okay, good. Good that you're noticing all of these things. Do you see how 5 divided by 4 is 1 1/4, and 11 divided by 4 is 2 3/4? That makes sense. Okay. Well, I think that's pretty good. Let's look at one more thing, which is how useful are tape diagrams in modeling division? Does it help to see the total and how many parts you're breaking it into? What would this tape diagram represent? 1 divided by 4. Yes? And do we know what 1 divided by 4 is? 1/4, right? Because division is a fraction. Awesome. Thanks so much for watching carefully. Aloha and mahalo.